What's hot and cold with heat exchangers? Heat exchangers, what are they? They are super important devices. You find them in so many places. Their main job is to move heat energy that is, from one fluid to another fluid, without the fluids actually mixing. Think of it like a high five for heat. One hot fluid passes its warmth to a cooler fluid, making it warmer. Why is this so important, you ask? Well, consider your car's radiator. That's a heat exchanger. It keeps your engine from overheating. Your refrigerator uses them too, to keep your food cold and fresh. Air conditioners, you guessed it. They use heat exchangers to cool your home. These devices are all around us, working silently, making our lives more comfortable and efficient. Industries love heat exchangers. Power plants use them to make electricity. Chemical plants need them for processes. Food and beverage industries use them for pasteurization and cooling. Oil refineries and HVAC systems too. Let's talk about shell and tube exchangers. These are a very common type. Picture a big, strong outer shell. It's like a large cylindrical container. Inside this shell, there are many tubes, a whole bundle of them packed neatly. One fluid flows inside these small tubes. We call this the tube-side fluid. It's a simple yet very effective design used for many, many years in industry. So how does it work its magic? The first fluid flows through the tubes. The second fluid flows outside the tubes, but still inside the main shell. This is the shell-side fluid. Heat transfers through the walls of the tubes, from the hotter fluid to the colder one. Often there are things called baffles. These direct the shell-side fluid flow, making it more efficient at picking up heat. Why are shell and tube types so popular? One big reason: they are tough. They can handle very high pressures and also very high temperatures. The cylindrical shell is strong, the tubes are well supported inside. This makes them reliable for demanding jobs when things get hot and pressurized. Now, let's switch gears to another star, the plate heat exchanger. These look quite different. Imagine a stack of thin metal plates. These plates are usually corrugated, meaning they have wavy patterns. Gaskets are placed between the plates. These create sealed channels for fluids. The plates are pressed together tightly in a sturdy frame, holding it all together. How do these plates exchange heat? Well, it's pretty clever, you see. Two different fluids flow through in alternating channels created by the plates. So fluid A is in one channel, fluid B is in the next, then A again, and so on through the stack. The thin plates allow for rapid heat transfer from the hot fluid to the cold fluid. The corrugations create lots of turbulence. Plate heat exchangers are known for efficiency, that large surface area from many plates. And the turbulent flow are key. Turbulence helps mix the fluid, bringing more of it into contact with the heat transfer surface. This means they can transfer a lot of heat in a relatively small package, so they are very compact. All right, let's dive into section 4, head-to-head, shell and tube versus plate, a feature showdown. So let's compare these two types directly. First up, we've got thermal efficiency. Plate heat exchangers usually take the lead here. Their thin plates and high turbulence mean they transfer heat exceptionally well. They can achieve very close temperatures between the hot and cold fluids. Now, shell and tube exchangers can be efficient too, but they often need more surface area, and as a result, they tend to be larger for the same effect. Next, let's consider space requirements. Here's where plate exchangers really shine. They're much more compact for a given heat transfer duty. Their design packs a lot of surface area into a small volume, it's true. On the other hand, shell and tube exchangers are bulkier. They often need more floor space and can be quite long and heavy. This is a big factor in tight spots. Now, what about maintenance and cleaning? Well, plate heat exchangers are often easier in this regard. You can disassemble the plate pack for full access to clean the surfaces. Moving on to section 5, choosing your champion, picking the right heat exchanger. So, how do you choose the right one? It really depends on your specific needs. Think about the operating conditions. What are the temperatures involved? What are the pressures like? Are the fluids clean or dirty, corrosive, prone to fouling? These are all critical questions to ask. Each type has its strengths and its limitations, you see. Consider a shell and tube exchanger if you're dealing with very high pressures or extremely high temperatures. Perhaps one of your fluids is very dirty or could cause a lot of fouling. If you need something super robust that can handle tough process conditions, And if space isn't your biggest constraint, then shell and tube might be your hero. It's a reliable, proven technology. Now think about a plate heat exchanger if you need very high thermal efficiency and space is at a premium. If your fluids are relatively clean and operating pressures and temperatures are within moderate limits. If ease of cleaning and maintenance is a top priority for you, especially for food or pharmaceutical uses, then a plate exchanger could be perfect. Ultimately, the choice is yours. Based on careful consideration of all these important factors, sometimes the best solution might even be a specialized type of heat exchanger or a combination of technologies. For very complex applications, it's wise to consult with heat transfer experts.